Hello students, in today's class let us continue the chapter surface areas and volumes. Almost we have done with the chapter frustrum. Frustrum topic has been deleted from 2021 syllabus. So directly we will move on to exercise 13.5. Again, if you see, it's an optional exercise, and in this the last three problems are related to frustrum only, 5, 6, 7. So we are going to see only question number 1 to 4. I will explain how to do it, and I have solved even for you, but I want you to redo it, right? So first let us get into the first question. A copper wire 3 millimeter in dia is wound about a cylinder whose length is 12 centimeter and dia 10 centimeter so as to cover the curved surface area of the cylinder. Find the length and mass of the wire, assuming the density of copper to be 8.88 gram per centimeter cube, right? So what is given? A copper wire is wound around a cylinder, right? And they asked you to find the length of the cylinder, length of the wire required, and also the mass of the wire. The dimensions of the wire and the cylinder both are given in the question. So let us see how can we solve this problem now. So for the copper wire, the dia is 3 millimeter and if you see, it is in millimeter, the other dimensions of the cylinder are in centimeter. So let us convert this also in terms of centimeter. We know 10 millimeter equal to 1 centimeter. So 3 by 10 centimeter. So when it comes to radius, again it is going to be 3 by 10 divided by 2 because this is dia, right? So radius is 3 by 20 centimeter, and so the dimensions of the cylinder are also given in the question. Now first let us find the length of the wire required to wound the cylinder. And if you imagine, this is a cylinder and this is the copper wire which is rounded around the cylinder, and if you examine it properly, we can come to a conclusion that if this two line is a wire, right? This is a wire. So one time when it is covered, the cylinder, how much height is being occupied? It occupies the dia of the wire, right? This becomes the height of the cylinder. When it comes to the second round, again second dia, right? When it comes to the third round, it is third dia. Like that, it covers the entire cylinder. And one more thing, if you analyze, length of the wire for one round will be equal to the circumference of the base. For one round, it is circumference of the base because it is around the cylinder, right? But the circumference of the base is nothing but circumference of the circle, which is 2 pi r, right? So radius of the cylinder is given as 5 centimeter. So length of the wire for one round is going to be 10 pi. Now we don't know how many rounds it will make to complete the cylinder, right? So first let us find how many rounds of the wire is needed to complete the cylinder. Number of rounds is equal to height of the cylinder divided by the dia of the wire. Why it is dia of the wire? That's what I explained here. If you see, if you analyze it properly, this two lines is wire, one round it makes. So it occupies this much height, right? This much height of the cylinder. But what is this? This is nothing but the diameter of the wire, right? So how many diameters? If you divide the height of the cylinder by the dia of the wire, we will come to know how many times, how many rounds the wire make to cover the entire cylinder. Hope you got it. So height of the cylinder given in the question as 12 centimeter divided by dia is 0.3 centimeter. So if you divide, we got 40 rounds. So 40 rounds it makes to complete the cylinder. Therefore, we know length of the wire for one round. Therefore, length of the wire in 40 rounds is going to be 10 pi multiplied by 40, right? So that will give you the length of the wire. Now we need to find the mass of the wire. What is mass formula? Mass is volume into density. So first we need to find the volume of the wire. How to find the volume of the wire? Area of the cross section multiplied by its height, right? area of the cross section multiplied by its height. Since it is wire, the height is considered as the length of the wire, right? Length of the wire. And since it is a wire like this, it is a wire, right? So it will be like this, right? So the length of the wire is the height. Length of the wire is the height, and the cross section is going to be circle. So the area of the cross section is pi r square. So radius is 3 by 20 because the wire's radius is 3 by 20. So 3 by 20 into length of the wire, we found it as 12.57. So if we simplify all these, we will get the volume of the wire. But they asked you to find the mass. Mass is volume into density. And in the question it is given density of copper wire per centimeter cube is 8.88 gram. Therefore, volume of the wire multiplied by the density will give you the required mass of the wire, right? Hope you got it. I repeat what we have done here. They asked you to find the length and the mass of the wire which is rounded around a cylinder. So first we found the length of the wire needed to cover one round, which is nothing but the circumference of the base. And then we found how many rounds it is needed to cover the entire height of the cylinder, which is height of the cylinder divided by the dia of wire. So using this we found the length of the wire needed for that many rounds, right? This gives the length of the wire. Then to find the mass, first we found the volume of the wire. Volume of the wire is area of cross section into its height. So we found height of the wire is going to be its length, right? And then after finding the volume, we multiplied by its density to get the mass. Yes, hope you understood. Let us move on to the second question now. Now we are in the second question. A right triangle whose sides are 3 cm and 4 cm other than hypotenuse is made to revolve about its hypotenuse. Find the volume and surface area of the double cone so formed. Choose value of pi as found appropriate. Alright. So this is an easy question. What is given? A right triangle. So a right triangle is given, right, and AC is the hypotenuse and is revolved around its hypotenuse. That's what given in the question. So a right triangle, the angle opposite to hypotenuse is going to be the right triangle. So this is 90 degree. So this triangle is being revolved around its hypotenuse. So obviously we will obtain two cones. One is at the top and the second one is at the bottom. They asked you to find the volume and surface area of the double cone. Right? What is volume of the cone formula? 1 by 3 pi r square h. So to find the volume, we need to know the radius and the height of both the cones. So OB is going to be the radius and OA is going to be the height of the first cone and OC is going to be the height of the second cone. So only if we know the radius and the height, we can find the volume. Similarly, surface area of the cone formula is pi RL. We need to know the radius and the slant height. Slant height is known, which is given in the question. So before we get into the actual question of the problem, first we need to find the radius and the height of both the cones. Radius is going to be same for both the cones, right? So first, in order to find the height, we will use the Pythagoras theorem. Since it is a right triangle, we know AC square is going to be AB square plus BC square. So if we substitute, we can find AC is 5 centimeter. Now in order to find OB, what are we going to use here is, we are going to use the area of the triangle formula. That's what normally we will do to find the height, right? We will find the area of the triangle in two ways. So half into base into height is the area of the triangle. So one way, we are going to take BC as our base and AB as our height. Since this is 90 degree, AB is the height, perpendicular distance. So BC we have taken it as base and AB as our height. The other way, we are going to take AC as our base and OB as our height. This is also perpendicular distance we are going to take, right? So AC as our base and OB as our height, since we need to find what is OB. We know all other remaining values, AC, BC and AB. If we substitute, we can find OB as 12 divided by 5, which is 2.4 centimeter. Now we found the radius, and when it comes to height, AO plus OC is 5 centimeter. AC is 5 centimeter. So volume of the double cone is going to be volume of cone 1 plus volume of cone 2, 1 by 3 pi r square h1 plus 1 by 3 pi r square h2. Radius is common, same radius, so we can take it as common, so h1 plus h2. The h1 plus h2 is nothing but 5. Together it is 5 because it's height of the first cone plus height of the second cone. The total distance is 5 centimeter. Length, right? So if you simplify, we can find what is volume. Similarly, surface area of double cone is surface area of cone 1 plus surface area of cone 2, which is pi r L1 plus pi r L2. L1 is 4 centimeter and L2 is 3 centimeter. Alright. So if you simplify again, we can find what is the surface area of the double cone. Yes. Hope you understood. It's an easy and simple question. Let us move on to the third question now. We are in the third question. A cistern internally measuring 150 centimeter cross 120 centimeter and 110 centimeter has 129600 centimeter cube of water in it. Okay. Porous bricks are placed in the water until the cistern is full to the brim. Each brick absorbs 1/17 of its own volume of water. How many bricks can be put in without overflowing the water, each brick being 22.5 into 7.5 into 6.5 centimeter. So what is given in the question? A cistern. A cistern is a tank which the dimension of the cistern is given, and this much water is already there in the cistern. Now they are going to place some bricks inside the cistern. In such a way, each brick absorbs 1/17 of its own volume of water. Right? So they asked you to find out how many bricks can be placed inside the cistern so that the water will not overflow. And the dimensions of the bricks are also given. Now let us see how can we solve this problem now. Now first let us find the volume of the cistern. Volume of the cistern is going to be L into B into H, right? So the dimensions are given. If we multiply, we got the volume of the tank. Now volume to be filled in the cistern. This is the total capacity. Already this much water is there in the tank. So this much can be filled further, right? So volume to be filled in the cistern is the total capacity minus volume of water which is already there. Now let us find the volume of the brick. Volume of one brick is going to be again L into B into H. If we take N is the number of bricks that can be placed in the cistern, then water absorbed by one brick is going to be 1/17 of its volume. So 1/17 of volume of one brick is 1096.875. Therefore, water absorbed by N bricks is going to be N divided by 17 into this. But according to the question, what you know, volume of this N bricks will be equal to water absorbed by N bricks plus volume of water to be filled. Right? That's what given in the question. What is given? The water should not overflow. Without overflowing the tank, we have to place bricks. In such a way, some volume of water is being absorbed by that many bricks, and the cistern is also not fully filled. Right? So the volume of the N bricks should be equal to the water absorbed by the N bricks plus the volume of the water to be filled. Right? Or else the same concept can be viewed in the other way. I'll explain that also. Whichever you understand, you can take it that. The other way you can see the question or understand the question in this way. Volume of water left in the cistern plus volume of bricks should be equal to the volume of the entire cistern. What does it mean? The volume of the cistern should occupy some number of bricks, that volume, plus already water, some amount of water is left in the cistern, right? So how do we know how much water is left in the cistern? Already 129600 water is there. Now if you place N bricks inside the tank, it will absorb some water. So from the amount of water, if you subtract the amount of water absorbed by that N bricks, will give you the water left in the cistern. plus the volume of all the bricks which you are going to place will be equal to the volume of the cistern. Yes or no? So there is a tank, there is some amount of water, and we are going to place some bricks inside the tank, and this bricks further it will absorb the water which is already there in the tank. So we have to find how many bricks can be placed in such a way the water will not overflow. So the volume of the entire tank should be equal to volume of the bricks plus volume of water left in the tank. How much water will be left in the tank? How much capacity is already there? From that we have to subtract the water absorbed by the bricks, right? So how will you get this? The capacity of the water which is already in the tank minus the water absorbed by the n bricks plus volume of n bricks. All these things we have found already, which is equal to the total capacity of the cistern, that also we found, L into B into H, right? So if you simplify, I can bring all the n terms to one side and the numericals to the other side. So we got 1096.88 n is equal to, if we subtract these two, we will get this plus this. This what we arrived here, right? So after simplification, we can find what is n. Since n denotes the number of bricks, we cannot give it in decimal, so give it as a whole number. Yes. So this is what the main concept according to the question. According to the question, volume of water left in the cistern plus volume of bricks will be equal to volume of the cistern. So for this, what are all the things we need? Volume of water left in the cistern can be obtained by how much water is available in the tank minus the water absorbed by n bricks. How can you find the water absorbed by n bricks? Volume of a brick divided by 17, because it absorbs 1/17 of its own volume. When it comes to n bricks, we need to multiply it by n. And again, volume of bricks is n times this, right? So the things which we need only we found it earlier, and we are going to substitute and simplify for n. Yes, hope you understood. Now let us move on to the fourth question. In one fortnight of a given month, there was a rainfall of 10 centimeter in a river valley. If the area of the valley is 7,280 kilometers square, show that the total rainfall was approximately equivalent to the addition to the normal water of 3 rivers, each 1072 kilometer long, 75 meter wide and 3 meter deep. So what is given? The rainfall in a river valley is given, area of the valley is given. We have to show that the total rainfall in that area is approximately equal to the normal water of 3 rivers, and the river dimension is given, right? So how will you find the total rainfall? Total rainfall is area of the valley into how much rainfall is there in a river valley. That will give you the total rainfall, right? Area into the rainfall, that will give you the height, like, right? So if you multiply, we will get the total rainfall. Now how will you find the volume of water in the 3 rivers? L into B into H multiplied by 3 rivers, because each river is of this much long, this much wide and this much deep. So if you multiply all the 3, length into breadth into height with 3, because 3 rivers are there, we will get the volume, and we will check whether the total rainfall is approximately equal to the volume of the 3 rivers or not. That's what, right? It's a very simple problem again. So area of the valley is given, the rise of water, that is the rainfall, is given in centimeters, so we will convert it into kilometer. Therefore amount of rainfall is going to be area into this, so we got 0.728 kilometer cube. Therefore volume of, next we will find the volume of water in 3 rivers. As I told you, 3 multiplied by length into breadth into height. Again, if you see, the dimensions are different, so be careful while substituting the values. So we converted into kilometer. We got 0.7236. Earlier we got 0.728. So they are approximately equal, right? And thus we came to the end of this exercise. As I told you, question number 5, 6, 7 are related to the frustrum. Frustrum topic is being deleted from your portion. So it is enough if we solve the first 4 questions. So in today's class, I want you to redo all the 4 questions even though I have done it for you. So today's homework is going to be exercise 13.5, question number 1 to 4. And if you have doubts, you can ask me. Thank you, students.